Okay. Let's do that. Okay. I don't know what it's doing. Whatever. All right, so there we go. Try that one. Y greater than minus 4x. So where do you start?
0.
Oh, the plus 0 again, huh? Start at 0. Okay, now where do we go from there? What do you do with that negative 4? Yeah, put it over 1, huh? Right, because negative 4 alone is the same as negative 4. Anytime you have a whole number, that's the same as being over 1. Over positive 1. Careful. Right? So we're going to rise negative 4 and run 1. So we're going to go down 4 over 1. You're going to go to the right. You're still going to the right one. Now, why? Because that negative doesn't go on both. You with me? It's not negative 4 over negative 1. That'd be positive. Right? It's not left 1. It's just down 4, right 1. Does that make sense? We good there? So there's our other dot. Connect the dots. Like that. Down 4 over 1. Now, which side are we going to shade? Oh, it's another dotted one. They're almost all dotted, aren't they? So it's another dotted. So which side are we going to shade? Yeah, y is greater. So the shade above it. Yeah. Questions I can answer? Is that making sense? No questions at all? We all good? Not all good on that? All right. Now you can graph these on your graphing calculator as well, by the way. You know, put them in there and take a look at them. Get the lines as a double check. Use your graphing calculator on the test. Double check your work, right? Type those in, right? You can just type into your graphing calculator y1 equals 8x minus 2 and y2 is minus 4x plus 4. Right? Graph them both. It'll show you both lines. It might be hard to still find the exact dots. You know, you'll probably need to do some by hand work to get the exact dots. And then you know the shading. You'll have to do the shading on your own because there's no shading on the. Well, there is, but it's complex. Rather than going into all that, just get the lines. You know the shading, right? Greater is above, less is below. So all right. So here we go. So y1. So let's do the first one here. So how do I graph y greater than 8x minus 2? Where do I start? Where's my first dot? Negative 2. Right there? All right, and how do I get to my second dot? Yeah, we start at negative 2. This is 8 over 1, huh? 8 over 1, right? Rise over run. So go up 8. Oh, 1, 2, 3, 4, 5, 6, 7, 8 over 1. Right there. So I went up 8 over 1. And then that's going to be a dotted line. Like that. Mine looks a little shaky. So there we go. Good so far. Now let's do the second one. Let me save the shading. Let me save the shading for a minute and do the second one. The second one, I'll do that in a different color. Where do I start for that one? 4. Yeah. For that one, I start at up 4. Right there. Like that. And then where do I go from there? Yeah, put this over 1. It's rise -4, run 1. So go down 4, which is here, and over 1. There. Right? Everybody see what I did? And then connect the dots. Like that. My lines look real shaky. There's that one. Further. Are we good to there so far? So far, so good. Are we happy? So are you ready for me to go to the next step? I got to do the shading now. So everybody get how I'm doing those lines, right? So I start for the black one. I started at -2, went up 8 over 1. Right? For the red one, I started it up 4, went down 4 over 1. So we got the 2 lines. Now, where's the shading go? Well, basically, there's 2 kinds of shading. The shading for the black graph, let's go back to the black, says y greater. So it's above the black graph. Which side's above? Yeah, look at that. Here's y -10. Here's y +10. This is above. Isn't that above? Right? Okay, now for the red graph, what does it say for that? Y less. Where's below the y? This is below the y, right? That's where the negative y values are. Okay, now where do the 2 shadings overlap? Because that's what we're looking for. The overlap. Let me let this keep going further. Where's the overlap of the 2 shadings? Can you tell? It's this region. Oh, come on. That's where the 2 shadings overlap, right? Right here, there's just red shading. Right there, there's just black shading. In all this, there's both shadings. So that's our answer. We're looking for where there's what's called the feasible region, which we're going to be talking a lot about that in days to come. That's where both shadings overlap. If you're in that blue region, you satisfy both inequality statements. Does that make sense? All the dots, there's millions. When I do that shading, this is like a big light bright. I think the best analogy for a graph is a light bright. Remember that old toy, light bright? I never had one of those, but I always saw the commercials, right? Little kids plug a little. That's what a graph is. It's basically little lights that are lighting up because they make the thing true. That's what it is, right? So everything in the blue zone makes both inequalities true. Their x and y values make both inequalities true. That's what that is. That's the overlap of the 2 shadings. All right. How would you do that? Okay. So x plus y less or equal to 1. Let's start with that one. So I want to graph both those. Even if you're going to use your graphing calculator, you're going to have to solve for y, huh? So go ahead. So we need to solve for y first on that one, right? So get y alone first. So what do we do to solve for y there? Yeah, grab that x and give it a little ride. Becomes negative, right? When things jump to the other side, they change their sign, right? Becomes negative x. We good there? So can you graph that one now? Just graph the line. Don't worry about the shading. We'll do both shadings together at the end. Well, you can do it now if you want. Maybe that's easier. I don't know. Whatever you like. So we started up 1. There's our first dot. And then how do we do the slope from there? Yeah, you make this a -1 over 1, huh? Everybody good with that? So it's rise over run, which means down 1 over 1. It goes there, doesn't it? Everybody see what happened? Right, it was you move that x to the other side, it's a negative x, negative 1 over 1. So from my first dot, which is at up 1, I go down 1 over 1. Everybody see that? So from my first dot, which is at up 1, I go down 1 over 1 to my other dot. That good? And that's a solid line, isn't it? Because we have the solid bar. The solid line. Which side's the shading on? Y is less. Below the line, right? Now let's do the next one. Next one is x minus y less than or equal to 5. Try that one. Get y alone again. Question?
If you divide by negative, does the sign?
Good. Remember, when you divide by the negative, the sign has to flip. Remember that from your algebra days? Those were some of the best days of your life, right?
Yeah.
So first off, grab that x. That'll be negative, and jump it to the other side. It becomes a negative x, right? Whenever something jumps to the other side, it changes the sign in front. There was nothing in front. It was plus, and now it's negative. And then, divide by the negative 1, because you got to get the y alone. You can't have anything in front of that y. So you got to divide by the negative 1, and that flips the symbol. Exactly. Good memory. So when you divide by negative, you flip the symbol. Totally. Good. So in the end, we've got y greater than or equal to, and x over negative 1, and positive over negative is negative 5, huh? Everybody see how all those signs changed? It's getting kind of messy. I can't even tell what's going on there. Let me go back to where it was before I messed it all up. It was originally y less than or equal to negative x plus 5, and then I divided through by negative 1, and the symbol flipped. Yeah, there we go. So see how the two negatives on the x? Oh, there's two. Yeah. That's going to be positive, huh? Positive. I'm messing that up. It just got so messy, I messed myself up. Yeah. So that's x over positive 1, because the two negatives made positive, huh? Good. And then over here, with 5, the positive and the negative made negative 5. Good. And there's really a 1 on the top of that x, huh? Because we always need a fraction next to that x for rise and run. Okay? We good there? Can you put that graph on there? Where do we start?
Negative 5.
Yeah, start at negative 5. Start down 5. Right there. Down 5. And then where do we go from there?
Rise 1, run 1.
Yeah, it's just up 1 over 1, huh? So go up 1 and over 1. Boom. Dot right there. Let's see what happened. Connect the dots. Pretty good with that? Right, so I started at down 5. I went up 1 over 1. Connect the two dots. Now, are we shading above or below that red line?
Above is greater than.
Y, yeah. You look at the very final statement of the y. Right, because that's when y is alone, right? And it says greater, so we're going to shade above it. So where do the two shadings overlap? It's this region, huh? That's what we call the feasible region. What does feasible mean? If something's feasible, what is it? I think that's feasible. What does that mean? It's doable, right? It's possible. It might work, right? It's allowable. It can work, right? So this is the feasible region. This is the region that'll work. These are all the points that make both equations. These are all the points that work for both equations. It's the feasible region. It's the allowable region. It's the possible region. You know, if we say that's feasible, we mean that's possible. That could do it. That could work. So that's what we're finding. So we're going to get to word problems. Then that'll be all the areas in which we could make all the conditions met. It's possible. We good there? You only have one letter for one of the equations. What does that mean that line's going to look like? Straight up and down or straight sideways, right? Yeah. Anyway, so go ahead. Try that first one. The first one's just normal. So that would be 3x plus y greater than 2. So try that one. That one's just normal enough. Get that y alone. I'm going to grab the 3x and jump it over. Becomes minus 3x. Sorry, good. Let me move it out of the way here. It's kind of an old graph. So we started up 2. And then the rise over the run. Down 3 over 1, boom, right down 3 over 1. Everybody good there? This can be a solid line or dotted. Solid bar, solid line. Everybody good with those 2 dots I got? So it up 2 and then down 3 over 1. And now do the other one. I'll do it in red. The other one is x less than or equal to 3. There's nothing to do. X is already alone, huh? Just run a line through the x-axis at positive 3. Then do the shading afterwards. Right? So run a line through the x-axis at positive 3. So that would be right here, wouldn't it? Right? Isn't that hitting the x-axis at positive 3? Didn't I run right through the x as positive 3? And which side of that am I going to shade? It says x less. It's the left side, huh? Oh, I forgot to do the black shading. So what was the black one? It was y greater. It's above the y. So where do the 2 shadings overlap? Right here. That's the feasible region. That's the possible region. That makes all the inequalities true. It's possible. Those are possible solutions. What we're going to do is we're going to end up finding the feasible region, which would be that. Then we're going to say, okay, that's all possible. Now, which answer in there is best? Which dot among that whole shaded region is the best answer to the real-life word problem? That's what we're going to. That's where we're headed. Being very real. All right, good. All right, we're putting the skills together to be able to. Okay, so we'll do one more of these, and we'll look at those word problems, and we're on to the next section. So try that one. So take the first equation, get x alone. Take the second equation, y alone. Get y alone in both cases, right? Get y alone for both those. Don't worry about the x greater than or equal to 0, y greater than or equal to 0. We'll do that. Well, in fact, let me just help right now. Do you know what this means, guys? When they say x and y greater, this means first quadrant only. That's all it means. Why? Because here's the x-axis. Where's the x's greater than 0? All these. Oh, no, that's the y's greater than 0, huh? Let me try this again. So these are all the x values greater than 0, right? This is where all the x's greater than 0 are. And where's all the y's greater than 0? It's everything above here. So where do the 2 overlap? First quadrant. It's just a fancy way for them to say, hey, ignore everything outside of the first quadrant. I only want x's and y's that are positive. Only x's and y's that are greater than or equal to 0. Positive, right? So in other words, so having said all that, let me make it even simpler. Just look with me for a second at the x-axis. See where the x's are positive? Not these. Don't want that negative x's. And look at the y's. See where the y's are positive? Don't want these negative y's, huh? So it's just here and here. It's just here, huh? The first quadrant is the only place where both x is positive and y is positive. So you don't need to do anything with that then. Just to save you time, because they're going to be doing that a lot from now on. When you see that x greater than 0, y greater than or equals 0, just go, oh, that just means first quadrant. And then just ignore them and do the rest of your work. All that means is don't let anything go outside of the first quadrant. All we're focused on is that upper right first quadrant. And that's going to be most word problems, because in most word problems, things can't be negative. You can't build a negative number of chairs or tables or, normally negatives are not in play. So this is a typical condition that we'll see on most of our word problems. First quadrant only. All right, so just do the rest of the work and only keep the answer in the first quadrant. So grab the x, jump it to the other side. We're trying to solve for y, right? Divide through by 3. That good to there? I got y alone real quick. All right, so we're going to graph that one now. Where do we start for the graph? Right up there at 4. And then how do we get it? That's our first dot. Is it up 4? How do we get our second dot? This is rise over run. What do we do to get our second dot? Yeah, down 1 over 3. Isn't it right there? I kind of missed. It's kind of small. There. So here's my first dot at up 4, and then down 1 over 3. There's my second dot. And then we just connect the dots. Solid line or dotted line? Solid bar, solid line. Which side's the shading on? Y is less. Shade below, right? But I don't care about that stuff that goes outside the first quadrant, really. It's okay, I'll leave it there, but really, in the end, I'm going to erase everything that's outside the first quadrant. So yeah, let me just do that right now. All I care about is the first quadrant. Does that make sense? That's what the x greater than x or y greater than 0. Yeah, you'll have to put in a separate, I'll show you. You have to put in a separate line, x equals 0 and y equals 0 and shade. Yeah. All right, now let's do the second equation. So the second one is 3x plus y less than or equal to 12. Solve for y, jump the 3x to the other side. We good? Where do we start graphing that thing? Up at 12. So that'd be like about up here, huh? Here's 12. And then go what? Yeah, down 3 over 1. So down to 9 over 1 right there. Right, good. Everybody see what I did? So I started at up 12. I went down 3 to 9 over 1. Down 3 over 1. Connect the dots. Oh, but actually, I only care about stuff in the first quadrant. So, and then where do I shade? Let's just say y, whoops, y less. Where's lesser stuff? Below the line. So where do the two shadings overlap? In this little section right here. See that little shape we have there? That's where all four inequalities are feasible. It's the feasible region. So yeah, so when you do the Math Excel homework, you're going to have to actually put on the graph x greater than 0. How do you do that? Well, that's hit the x-axis at 0. That's here. I just hit the x-axis at 0. And shade to the right, because greater. And then you're going to have to also put on the graph y, which is going to be here. Y greater than or equals 0 means shade above to get that to happen. See what I did there? So y greater than or equal to 0 is hitting the y-axis at 0 and shading up. And x greater than or equal to 0 is hitting the x-axis at 0, shading to the right. Want me to show you? Want to see?
I just can't put 12 on mine. I have the exact same problem as yours.
Just ask for a better one. Yeah, so here's what we're going to have to do on that. To graph that red one, which is supposed to start up, so just do it yourself, by hand, up at 12, and it's supposed to go, what, negative down 3 over 1, so it's supposed to be right there at 9, right? Because it went down 3. Well, guys, you can't go up to 12, so you've got this dot here, right, at up 9. Are you tracking with me? Because I'm going to do something. You guys good to there, right? Because the first one's at 12, up 12, but then go down 3 to 9 over 1. Just do that again. From here, go down 3, 1, 2, 3 over 1. So you see now you're at 6 over 2. This is going to be, right, over 2. So just do those two dots. Just keep doing the slope thing until you're on the screen. Down 3 over 1, down 3 over 1, down 3 over 1. You can get as many dots as you want. Make sense? So that's what we got to do. Do you guys like word problems? Are word problems your favorite? I used to be more sarcastic when I was a young teacher. As a teacher, when things start to get really hard in math, usually, especially the first couple of years I was teaching, the hand would shoot up in the air. Right, we're in the middle of the ugliest, hardest thing usually. I learned to predict it. Then the hand would shoot up in the air, and I knew the question that was coming. And it was, Mr. Heron, where are we ever going to use this stuff? Right? Where are we ever going to use this stuff? And really, I learned at first I was just kind of young and brash and, would just sarcastically answer. But then I learned over time, they're just sad. They're just like, this is killing me, Mr. Heron. I don't want this to be a real part of the real world because I hate this. Right? That's what they're really saying. This is hard. Right? So I used to answer their question, but that's not their real question. Their real question is, I don't like this. Can you help me make it through this? This is killing me. Tell me I'm really going to make it. But anyway, when I was a little more sarcastic, when they say, where are we ever going to use it in the real world? I'd say, would you like let's do some word problems. Then I'd show them the word problem. Then they like that less. So really, they don't want to see where they're going to do it in the real world. That's really the truth. Huh? So anyway, but I'm not that sarcastic anymore. All right, so here's the word problems. Here's where we'll see this in the real world. All right, so a company produces handmade shawls and afghans. They spin the yarn, dye it, weave it. Shawl requires 1 hour spinning, 1 hour dyeing, 1 hour weaving. Afghan requires 1 hour spinning, 2 hours dyeing, 4 hours weaving. There are at most 7 hours available for each day for spinning, 8 for dyeing, 12 for weaving. Summarize the data in the table. Use the table to write a system of inequalities. Graph the feasible region. All right. It's easier than it sounds. It sounds bad. So, shawls, hours spinning. Did they tell us that somewhere? Where is that? Oh, shawls, 1 hour spinning. So that's just a 1. And then 1 hour dyeing for the shawls. 1 hour weaving, shawls. Good so far. And then we'll do the afghans. And for the afghan, it's 1 hour spinning, 2 hours dyeing, 4 hours weaving. That good so far? And then those you just put your X and Y and your Z in there. Wait, I think, right? Yeah. Yeah, so see how the X's go across this way and the Y's go that way? So 1X plus, well, here, let me do the color scheme correctly. So 1X plus 1. Oh, wait, I'm confused. Oh, now I know. Now I'm thinking better. It's like that's an equation, huh? You see that? So that's 1X plus 1Y is 7. Actually, maximum means less than or equal to 7. Does that make sense? If something is a maximum, if I say, that there's going to be a max of 10 people get an A in this class, maybe, I don't know, then that means there's less than or equal to 10 people that'll get an A, right? Max means less than or equal, right? So then this is an equation, right? What is that? 1X plus 2Y less than or equal to 8. And this is equation 1X plus 4Y less than or equal to 12. See how I'm doing that? The X is the number of shawls and the Y is the number of Afghans. So those are the 3 inequalities they want us to write. And then they'll have you graph them like we practiced. Can I skip out of this and go on to other things? So you know the rest, right? You would just get Y alone for each equation, put the 3 graphs, right? Because when you go to graphing, you have to get Y alone, right? So we get Y alone for each equation, and then you'd have to graph. 10. Oh, I was just making that up. Nowhere. Right out of my head. I was just giving a real-life example of when I say maximum, that it means less than or equal to. Is that good? So then you just get Y alone for all 3 of those and graph them. Okay, let's go to the next, well, maybe. All right, so she works no more than 11 hours per week at the cafeteria. What is X? Oh, X, look down here. X is the number of hours at the cafeteria. So X is cafeteria. So if she works no more than 11, that's 11 or less. Less than or equal to 11, huh? If it's no more, then it's less or equal. You good with that phraseology? See how it says no more? If it's not more, it's less or equal. And it says the Y is the library, and no more than 16 at the library. So less than or equal to 16. No more, less. Right, good. And then finally, she must work at least 20 hours total. So X plus Y must be greater than or equal to 20. It must add up to be. At least means that or more, huh? If I have at least 20 coins in my pocket, I have 20 or more. It's a lot of coins in my pocket, right? At least means that or more. So there's our 3 equations. Is that good? And then you just have to get Y alone in this one. The other 2 are already good. And graph the 3 of them and find the feasible region. Find where the 3 shadings overlap. Good. Is that good? Let me do it real quick. If I got Y alone here, move the X over, right? Take the X and jump it over. It becomes a negative X. So when I went to graph that, I would start at up 20, wouldn't I? And then what would I do? Down 1 over 1? Yeah, I wonder if there will be a 20. Down 1 over 1, right, for the rise and the run. So you just go down 1 over 1. So there's a line right there, solid line.
Yeah, there is a 20.
Is there? Nice. Okay, and then let's do, here, I'll do some better color coding. Make this one, what was it, 11? Okay, how to do that one? Go over to 11. 11 would be about right here. X equals, this is the x-axis. You'd see 11 about right here. That was at 11. So, and then which way do I shade on it? X less. So lesser than that one. Oh, on the red one, let me go back to the red one. It was shaded Y greater, so above that one. And then finally, let me do a third one. This one, Y less than or equal to 16. So that would be go to 16 on the y-axis, about here, and shade below that one. So where do the 3 shadings overlap? right here, huh? I think, don't they? Oh, no. Is it here? Is it there? I think it's there, huh? Did I mess that up? I think it's up there. Yeah. Oh, I got tricked. It's above the red one, not below the red one, huh? Yeah. All right, you got it. Let's move to the next. All right. The graph, they're going to give you some nice pictures. The graph shows a region of feasible solutions. So suppose they've already done a bunch of graphing. They're kind of jumping you to the end now. They've already done a bunch of graphing, and this is the feasible region. This is the overlap of all the shadings, right? And they're saying find the max and the min values of the expression. This will be totally easy for you. So the expression, 6x plus 2y, what you have to do to answer this is you have to go to each, you find each corner and plug into 6x plus 2y. This will be easy for you. We don't know any reason why in the world we would do this yet. We're just kind of getting the tool ready. We don't know what the wrench is going to do. We're going to get to the real life job in a minute. But for now, let's just get good at using this wrench. What do I mean the corners? I mean this corner, this corner, this corner, and this corner. I just have to find the coordinates, read them off the graph, for those 4 dots, and then just plug each one into 6x plus 2y. Plug the x in for x, the y in for y, and whichever one comes out biggest, he's the highest, he's the max, and the smallest one's the min. And we're done. We have no idea why anybody would want to do such a weird thing. We'll get to that later. So let's take this first one. What's the coordinates of this first corner down here? Can you tell? Yeah, it's. Oh, did they tell you?
Yeah, right there. 2, 3, 5, 8, 8, 7. And
oh, look at that! This is great. They're just giving them to us. Yeah. I knew there was a reason I thought these were really easy. That's why I wasn't looking down. I looked at it earlier on my computer last week. That's right. They just hand them to you. I forgot. There's some reason I thought these were super easy. Yeah, they just give them to you. 2, 3, right? That you can tell that one's over 2 up 3, isn't it? That dot, this dot right here, is over 2 up 3. What's according to this side? This is over 8 up 4, and that must be one of the ones down here. No. Wait, I don't see 8, 4. Isn't that 8, 4? Oh, it's 9. 9, 4. I'm reading it wrong. That's my problem. It's not at 8. It's at 9, huh? It's at 9, 4. And then what's this one? This one's at 8, 5? 7. Wow, good thing they're helping me. And then this is at 5, 8. Right? Is that right? Yes. Anyway, there they are. You don't even need to do that because they've already given them to you. Just take them. So let me show you what we're supposed to do. I'll just do them in the order they have them here. 2, 3, 5, 8, 8, 7, and 9, 4. Right? Now, remember, the first one's x, second one's y, right? For all of them. Plug them in to 6x plus 2y. So what do I mean? I mean 6. Let me get rid of that. I mean 6 times the x, 2. Plus 2 times the y, 3. And work out the number. What is that? 12 plus 6, 18? Let's do the next one. 6x plus 2y again. 6 times the x, which is 5, plus 2 times the y, which is 8. What is that? 30 and 16, 46. Let me slow down for a minute. Does everybody see what I'm doing? I'm just plugging for each of these x, y numbers. I'm putting the x in for x, and the y in for y, and just working it out. 8, 7 into 6x plus 2y. X is 8, y is 7. 48 and 14, 58, 59, 62. And then finally, 6x plus 2y, 9 in for x. Whoops, messing up. And 4 in for y. 54 and 8, 62. All right. So which one came out the biggest? Is that 62? We had 2 62s. So they're tied. These are tied for the max, aren't they? And this one is the minimum, the lowest. Right? Because they're asking us which one's the max and which one's the min. So I'm going to have to see how we... Oh, they just want the value. So it's just 62. The max value is just... All they want is the 62. They're not even going to ask us which corner. The highest value is 62, right? The lowest value is 18. Does that make sense? 62 and 18. Let's go back and make sure. Okay, so now They're saying, okay, the graph shows the region of feasible solutions. Use the region to find the maximum minimum values we get an objective function. So, same thing. We got another function. Here's the corner points. They're telling us the corner points. So you just do the same thing. You just take 0, 6, and you plug into 2x plus 3y. So 2 times 0 plus 3 times 6. What is that? 18? And then, what's the next one? 8, 0? Plug in the 2 times x plus 3 times y. These are your favorite questions all semester, right? What's that, 16? And then finally, 3, 2. I'm just grabbing the corner points.
12.
Is that what it is? Yeah. 12. So this one's the max. 18 is the biggest. 12 is the smallest, huh? Is that good? Oh, that it was always like this, huh? So we're just plugging the corner points into that thing. They're now calling it by a new name. They're slowly bringing in the verbiage. They just called it the objective function. It's your objective in the word problem. In a minute, it'll become, well, next week, it'll become your objective. You're trying to maximize profit, usually, or minimize cost for a business. That's your objective. And you're finding the feasible region. You're going to check the corners and find the corner that does the best profit or the lowest cost. That's how it's going to work in real life next week. They're getting the tools ready for us now. And we're going to do as much as we can on the calculator, too. Yeah?
For this one, it said the maximum does not exist. Yeah, it's
Oh, of course they're right. Yeah, so how do I tell you that's the case? Yeah, okay. Yeah, so let me say something. Thank you. I'm glad you're checking it. I would have left it wrong. What it is, okay. Anytime, see how this one has, well, I don't need to redraw it. Why am I redrawing it? Here it is, right here. Anytime the shading goes up, up, and away, like Superman there, goes up to the right forever, when the shading goes up to the right forever, there's no max. Because you could get bigger and bigger and bigger and bigger forever. I'll explain. It'll make more sense when we have a real life problem in front of us. But let's just say for now, if the shading goes up forever, there's no maximum. So the minimum is still 12, and there is no maximum. Good. That baby went from crawling to running. All right. So let's do the whole thing. So we're not going to have time to finish completely, but let's just get started. So basically, the beginning of it is just graph them like we've been learning to graph. Don't worry about that maximum thing. That's the thing we'll do at the very end. We're going to plug in we're all done, and we have a picture, and we have like a feasible region. We're going to find the corners and plug them into that maximum thing. So we won't use that till the end, and we'll just find the one that's biggest, and that'll be our answer. All right, so let's ignore that, and let's just work with these three for now. Oh, and you know what the x greater than or equals 0, y greater than or equals 0 means? What does that mean? First quadrant. Remember, that means positive. Both are positive. Yeah. So that's all that means. Don't need to do anything with that. That's first quadrant. These guys. First quadrant. Okay. So really all I got to work with is these guys. Let me start with this one. 5x plus 7y less than or equal to 35. So how do I go about graphing him? Jump that 5 again. Get y alone. Jump that 5x over there. Becomes a negative 5x. Divide through by 7. Good to there. And then I'll grab the second one and and I'll graph him in a minute. Let me just get them both ready. Grab this one. 11x plus y less than or equal to 35. Get y alone again. Jump the 11x over. Whoops. Becomes negative 11x. So that one's ready to go, and that one's ready to go. So now I'm going to graph them. And I would also encourage you to type them into your graphing calculator. We'll do some of that next week. But you type them both into your graphing calculator, and that would help as well. Kind of do by hand and by calculator both. So we good. I'm going to go to a new screen. If you've got that copied down, and graph those. We'll just do it quick and probably review it next week. So there we go again. Everybody get those copied down, those two y functions. So y less than or equal to negative 5/7x plus 5. So we have y less than or equal to negative 5/7x plus 5. And then the red one was less than or equal to negative 11x plus 35. Okay. All right, let's go to a graph. Oh yeah, let me make this graph as easy to read as possible. Look at what I'm doing with my graph. I'm not even going to draw the second, third, or fourth quadrant. See, I'm just drawing the upper right-hand corner because it's only first quadrant. That's pretty much what we'll do from now on. We won't mess with the other quadrants. Okay, so where do these go? You start here at up 5. 1, 2. Ooh, I need to start. This one's going to start at 35, so I better leave a little room. It's good to look in advance at kind of where you need to end up. So I'll just say, hey, that's 5. And I'm not going to make all the marks. Started up 5, and then this one goes what? Rise over run. So it's going to go down 5. Down 5, you're there. Over 7, you're there, huh? Does that make sense? And so there, and I don't care about where it goes outside the first quadrant. There's that line. And we're going to shade y is less. We're going to shade below that. Now let's do the red one. And that's going to be start at 35, so way up here at 35. And go, put this over 1, down 11 over 1. So how do you do that? Go down 11 over 1. Something like 11. What you subtract 11 from that? You'd be at 24, huh? Over 1. So this dot's at over 1 up 24, isn't it? So it's going to do something like that. Is that good? I don't know exactly where it's going to hit. My graphing calculator will tell me all that. I'll let the details, I'll let the calculator tell me the details because they're painful. Math Excel shows you how to work them out. They take forever. I used to make students do that. I was mean back then. All right. So this is y less. And so less is like that. So where do the two shadings overlap? What's our feasible region? It's right here, isn't it? Then basically we're going to find these 4 corners of the feasible region. Our graphing calculator will do that for us next week. We'll find those 4 corners. We'll use the intersection routine. Remember how we did an intersection of 2 lines? We'll basically ask our calculator to do that. Plus, well, we know this one. This one's the origin. And then this one's the intersection. These 2 we'll find by value on your graphing calculator. And this one is, no, this one by, I'll show you next week. Anyway, we'll find all those dots by the graphing calculator. And then we'll take those dots and we'll plug them into the that original maximum z thing and take the biggest and the small, or the biggest, they just said max. That's all preview of coming attractions for next week. All right, guys, just